The next activity that we'll take part in is activity number 12 on page 105 of our workbook. This is a maximum demand of a factory spread across 3 phases. As this activity revolves around the maximum demand of a factory, we'll consult table C2 of AS3000. Table C2 talks about non-domestic electrical installations and is further broken up into 2 sections. The first one being a residential institution, such as hotels, boarding houses, hospitals and accommodation, etc. And the second would be factories, shops, stores, offices, schools and churches. Broadly speaking, we'd suggest that column 2 relates to installations where one would sleep, and column 3 would relate to installations where we probably wouldn't sleep. As with the previous activities, the loads are listed onto the job, and step 1 is we'll start to break down what load group each one relates to. The first load group is 6 high bay mercury vapour luminaires rated at 2.6 amps each on one circuit. Lighting comes under load group A, except for specialist lighting that is in load group F, and we'll see later that load group F is fuel dispensing units. So we're going to stick with this particular lighting being in load group A. The calculation for this one is full connected load. So we'll populate our spreadsheet accordingly. So I've now listed load group A being mercury vapour lights. The calculation used will be 6 of at 2.6 amps each. Gives us a total of 15.6 amps. Now it said earlier in the description that these were on one circuit, so we've allocated that 15.6 amps straight onto A phase. Secondly, we have 30 twin 36 watt fluorescent lights rated at 0.333 amps, each on one circuit. We already know that lighting is classed with full connected load, so we'll populate the next part. So once again, load group A, 2 36 watt fluoros, gives us a total of 10 amps. Thirdly, we'll have 20 10 amp double single phase socket outlets spread across 5 circuits. Socket outlets fall under load group B. Further, we will break down load group B into B1, B2 and B3. Load group B1 talks about socket outlets not exceeding 10 amps other than those in B2, and B2 is socket outlets not exceeding 10 amps in buildings or portions of buildings provided with permanently installed heating or cooling equipment, or both. Essentially, the big difference there is that the socket outlets are in a factory area or an office area associated with the factory. Because the description in our task exercise doesn't stipulate whether it's inside a air-conditioned area or outside, we're going to default that it's outside the air-conditioned area and it's actually on the factory floor. The exercise stipulated that there's 20 10 amp doubles. Further, with regard to socket outlets, you'll notice that there's a footnote 3 and 5. So let's just quickly check what that footnote says. Footnote 5 says, for the purpose of determining maximum demand, a multiple combination socket outlet is regarded as the same number of points as the number of integral socket outlets in the combination. Simply put, a double socket outlet would count for 2 points. This has not always been the case, and previous editions of AS3000, admittedly some time ago, have always stipulated something different, but now we know that each double is actually worth 2 points. A triple would be worth 3 points, and a quad setup would be worth 4, etc, etc. Further, we have to break up each one of these 20 because it says that they want it spread across 5 circuits. So if we've got 20 double single phase outlets across 5 circuits, we'd have 4 double socket outlets on each circuit. Let's have a look at how we'll break that up. With your 10 amp double socket outlets, we need to spread those across 5 circuits. From a design point of view, that means that two phases are going to have two circuits each, and one phase is going to have one circuit. Further breaking that down evenly, we'd say that there's going to be 4 doubles on each circuit. I've decided that two phases, those being C and A, will have 8 doubles each on them, and B phase will have the 4 doubles. That accounts for my 20 double outlets. As we previously saw, each double would be worth 2 points. So the calculation for this maximum demand would be, for the two phases at the start, we'd go with 8 doubles, so 1000 watt initial allocation, and then 750 watts for each one after. In the case of two phases, there's going to be 15 others. In the case where there's only 4 doubles, there'll be 7 others. So the initial one gets 1000, and then in this case, it's another 7, making it 8. That accounts for our 4 doubles. Phases C and A both are allocated 53.3 amps, and the third one, being phase B, will get allocated 27.2 amps. The next load group on our list is 4 20 amp 3-phase socket outlets. 20 amp socket outlets fall under category B, which is socket outlets, and subgroup 3, socket outlets exceeding 10 amps. The calculation provided for this will be the full current rating of the highest rated socket outlet plus 75% of full current rating of the remainder. Filling out our form now, load group B3, the load being 4 20 amp 3-phase outlets, and the calculation being 20 amps for the first one. Then we have 0.75 of the remainder. So 0.75 times 20 times 3, because there's 3 of them, which gives us 4 in total. So we have 20 amps plus the rest of it, which equates to 45 amps. We'll now allocate a total of 65 amps on each phase, being 3-phase outlets. The next group is 4 3-phase induction motors rated at 32 amps each. Looking down through our load groups on table C2, we find motors that are other than in load group E and F. Load group E being lifts, and load group F being fuel dispensing units. So load group D, and the calculation is full load of the highest rated motor plus 75% of the full load of the second highest rated motor and 50% of full load of the remainder. Let's now populate our sheet. So in total for load group D, we've got 32 amps plus 24 amps for the second one and 16 amps each for the other two, which is 32 amps, which gives us a total contribution of 88 amps each. The next load group is one 400 volt 2-phase arc welding machine with a rated primary current of 40 amps. The 400 volt 2-phase means essentially it will be going across 2 phases only. So we'll now have a look at what load group that's in. Welders are covered in load group H. And the description is, in accordance with paragraph C2.5.2, taking into account any power factor correction. Let's refer to paragraph C2.5.2 welding machines. Several pages later, we'll describe the definition of a welding machine, how the rated primary current is calculated, there's actual primary current explanations, duty cycle, etc., etc. Looking on the next page, we see reference to an arc welding machine, and that's the sort of machine that's listed on our task. So paragraph C2.5.2.2 talks about arc welding machines and says, under point A, individual machine, the maximum demand of an individual arc welding machine is deemed to be 100% of the rated primary current. I've now populated my sheet with load group H and the 40 amp two-phase welder. Calculation is full connected load, and now I'm going to put 40 amps across two phases only. Now a quick peruse down there will tell me which ones I can afford to load up, bearing in mind that we need to maintain an out of balance current of less than 25 amps per phase in accordance with the New South Wales service and installation rules. I note that C phase is considerably lighter loaded than some of the others, so that will be my first one. The next lightly loaded phase would be B phase. I'll place the other on B phase. Finally, I have a 4.4 kilowatt 230 volt hot water system. A quick look down the load groups of table C2 sees load group C, appliances for cooking, heating and cooling, including instantaneous water heaters, but not appliances in load group D and J. Our task involves a 4.4 kilowatt 230 volt hot water system. I generally consider that to be a storage unit. So we'll continue to look through the load groups. Load group G talks about heating elements associated with thermal storage heaters, including water heaters, space heaters and similar arrangements such as swimming pools, spas and saunas. It would be my suggestion that a 4.4 kilowatt 230 volt hot water system would be more appropriate to place in load group G than load group C. I've now populated my sheet. Obviously I've gone outside the lines because I took up 2 lines for a clearer explanation of B1, but that's okay. Load group G, hot water system, the calculation being 4,400 divided by 230, which gives me a total full load current of 19.1. I'll place that 19.1 amps on A phase. The next task in the activity is to add up the subtotals of all of the phases. After totaling all of the single phase demands, I have a total of 241 for A phase, 230 for B phase and 246 for C phase, taking into consideration some sort of rounding. My initial check would be to ensure once again that I am within 25 amps from the lowest to the highest phases in accordance with the New South Wales service and installation rules. And if I'm satisfied with the distribution amongst the phases, I could then draw a conclusion that on this particular task that my maximum demand is 246 amps. One of the most important things to note at this point is that we do not add them all together. And on several occasions we see that people add all of the phases together in order to give us an outrageously high maximum demand. Remember, the whole purpose of doing a maximum demand is to find out what size cable will I run for the consumer's mains to power this installation. So obviously if I've got 246 on C phase, there's no point trying to find a cable that's going to run, for example, 650 amps or whatever the total of these would be. The next stage really though would be to have a look at the next size up protective device so that we meet the requirements of IB is less than or equal to IM, which is less than or equal to IZ.